Hello and welcome to the webinar on AnyLogic Cloud and its uses for server-based multi-run experiments. My name is Arash Matavi and I'll be your host today. Today with me we have Tyler Wolf-Adam, who is the simulation modeling specialist at AnyLogic North America, and Jeffrey Worth, who is the program support specialist here at AnyLogic North America. We have a pretty jam-packed webinar with lots of information for you. And as you see on the screen, this is the agenda for today's webinar. We'll start by some introduction about the AnyLogic ecosystem, life cycle of simulation modeling, and why we prefer to run multi-run prescriptive experiments on servers which gives us more computational power and flexibility to run these experiments at scale. Then I will go through a short lecture about different types of multi-run experiments that we can run on AnyLogic Model Manager, and why we do this and what type of uncertainty and prospection we are trying to do with each type of these experimentations. In the second half of this webinar, both Tyler and Jeff are going to demonstrate how these technologies and experiments can actually be executed with AnyLogic Model Manager or AnyLogic Cloud. First, Jeff will walk us through how we can prepare a local model before we deploy it on the server. So these are the preparation steps to make sure that your base model is ready to be turned into a experimentation environment. And then he will show us how we can set up different types of multi-run experiments within Model Manager through its built-in UI or user interface, how you can create dashboards, how you can share models, and all the great kind of utilities that comes with the Model Manager. And at the end, Tyler will show us another aspect of models that are deployed on AnyLogic Model Manager, and that would be how you can set up experiments with the help of its API or programming interface. So that gives you another layers of use cases and usability for multitude of applications, which we will discuss when we get there. And at the end, we will leave you with more references and resources for you to explore these topics if you're interested to explore and build models and experiments as we are going to discuss in this webinar. And at the end, the three of us will join you again in a live Q&A session to answer all the questions that might left unanswered during the live chat. Now we are going to start the first part of the webinar. So Tyler is going to leave us for a few minutes, and me and Jeff will go through the introduction and setting up experiments with the AnyLogic UI. So let's start by some of the basics and some definitions to make sure we are on the same page. The first thing that I wanted to discuss is what is dynamic simulation and why we use it. One easy way to describe it would be as dynamic simulation is a prospection technique which enables businesses to see the impact of decisions before implementation of those decisions. And that gives them the opportunity to optimize their existing operations or basically enhance what they want to do based on the information that they gain from looking into the future. And the other way to look at it is that the simulation modeling gives you this tools and techniques to recreate a digital version of your real assets, and now you will have a digital playground or environment to test different hypotheses and basically make decisions based on previously tested ideas in a risk-free space. One other thing that I wanted to mention is a larger trend about how the life cycle of a simulation model has changed over the past few years. As you see on the screen, there are two major phases in the life cycle of a simulation model: creation and use. And creation part is what all of the simulation models are very familiar with. You need to understand the system that you wanted to model, gather the data, kind of model and incorporate all the logic that you learned from SMEs and put them into a model that represents reality. And then you can run this model or execute it, which kind of turns into the use case, and gain some insight from its prospection capabilities. As we will see here, there are many different multi-run or experimentations that can help you to gain these insights in a very useful way. And the trend, as you see on the screen, is with the digital transformation being the main driver to keep the usefulness of a model more, or basically increase the lifetime of a model in its use phase. So we can run more experiments and keep using it as a tactical or even an operational tool that can help us make decisions on a more operational level. So next, we wanted to take a look into the AnyLogic simulation software ecosystem. And as you can see on the screen, we have the AnyLogic model editor. This is a desktop application software that lets you to create your real assets, or basically recreate a digital version of your real assets inside this simulation environment. And definitely you can run experiments locally on the same machine. But as I mentioned, as the complexity of your simulation model grows and the experimentations that you want to do on those models also are going to become more computationally expensive, more recent models and contemporary models have the tendency to require lots of computation. And because of that, and lots of other reasons, we created the model manager to let you to run these multi-run experiments on a more powerful server that also acts as a centralized location for all of the modelers that are working within an organization, and they can put all of these models in one centralized repository and run these kind of more sophisticated experiments on the server side. This also gives the end users, which are probably your colleagues, your management, and other people inside the organization who want to run these experiments but not necessarily have any logic editor, to be able to get access to these models and run them and experiment and gain insights from them. These people could also be the analysts that interact with the models through API calls, something that Tyler will show near the end of the webinar. So our focus for today would be to first review the different types of multi-run experiments that we can do on the model manager, and also give you a pretty thorough overview of how you set up your models here, get them ready to be uploaded on the model manager, create your dashboards and experiments here and run them on the servers through the built-in UI, and eventually how to run those experiments through API access if you don't want to use the built-in UI, or you have some use cases that needs incorporation of the simulation outcome into different workflows. So next, I'm going to review the 4 levels of uncertainty that we face when we wanted to make decisions. And this will give us some ideas about how experimentation with simulation can help us to make decisions under uncertainty. These slides that I will show are come from an Harvard Business Review article, and I didn't change them that much. So let's just review them and see different types of uncertainty that we might deal with when we are trying to make decisions. At level 1, we have scenarios that we basically can observe a clear enough future, meaning that things are simple, there are not that much nonlinearity or dynamic interactions involved, and the system works in a more or less deterministic way, and we can actually forecast or see the future state of the system pretty easily. And there are many things that can be done. A deterministic simulation could be a solution here, but probably just a simple regression could lead to a pretty useful answer. Level 2 is when the uncertainty that we are dealing with is actually show itself in alternate futures, meaning that even when we start with a specific state, that might lead into multiple alternatives, or we have alternatives that we can try, or they're all viable alternatives, but we wanted to see what would be the end state of each of those alternate futures. Simulation definitely can help us with these type of scenarios a lot. And the next would be when the uncertainty in the future is actually not just some discrete futures like the previous level 2, but rather a range of futures. So we are looking at a space of possibilities. Again, simulation is one of the most equipped tool sets for this type of scenarios. And we'll look into specific experiments that will help us with reviewing and actually exploring a range of futures. And level 4 is basically we are dealing with true ambiguity. This is not something that anybody can do any prediction with. The solution at these kind of situations is to go back and try to understand more about what's the underlying unknowns and uncertainties are to hopefully bring this back into level 3 or 2. Okay, so now with this framework, let's get into how simulation experiments can deal with these different levels of uncertainty and help us make decisions. Okay, before I start to get into each of the experiments that you can actually execute on Model Manager, I want to talk about a specific concept to make sure that we're on the same page and kind of describe what these schematics mean. Here, I'm showcasing 2 different types of systems or simulation models. The one on top is internally deterministic, which means that if you run the model, this play button actually represents running or executing a model. If you execute a model with a constant initial state, so you set some initial state and then run a model, it will get you to an endpoint. And if you repeat that, you get to the exact same endpoint because you're dealing with a model that's internally deterministic. So nothing inside the model will give you different paths to explore. One other thing that I wanted to mention about this schematic, this straight line doesn't mean that no change happened during the simulation. The inner state of the model will change, and we can track that. What this straight line means is there won't be any other path or alternative path from when you start the model to the endpoint, and you get there without any kind of alternative path, basically. And as you see, the end result is just 1, and you run with the same input, you get the same output. It's pretty straightforward. And you might ask why you even bother with simulation if we are in this kind of situation. There might be some complex dynamic behavior in a system that even if it's deterministic, the nonlinearity or, as I said, dynamic interaction between the components make it pretty hard to manually guess what the end state would be, so you wanted to simulate it. But that's a good question if you have that in mind, because most of the simulations have some randomness or stochasticity internally, and that's what makes it more interesting and more realistic, which is the second case. So here, I'm depicting an internally stochastic system. So as you can see, if we run the same model 3 times, these are 3 runs, with the same exact constant input. So we haven't changed the input. We start from the exact same initial state. Because there are internal randomness built into it, multiple paths are possible. And we ran it 3 times, so you see that 3 of those paths reached their end state, and we have these dots representing those. There might be many more paths that are still possible, but we ran only 3 of them. So if you ran more dots might actually show up, and if you keep doing this, eventually you will end up with a distribution of all the possible outcomes for a certain value that you're measuring in this system. So that is the main kind of idea that separates the internally deterministic from internally stochastic models. So with this in mind, we're going to look into experiments that we wanted to explore, knowing that realistically, most of the time we build simulation for systems that are internally stochastic. So let's start by the simulation experiment, which is the base experiment that we run every time we build a new model. Simulation experiment runs model simulation with animation displayed. So one major factor that you should keep in mind when you're running simulation is that because it's one run, definitely you have access to the animation. You can actually observe how the state of the system changes through time. So I showed 2 categories of models. Let's say we have an internally deterministic model. If we run it with a constant input, we basically run the simulation, you get to one outcome, and this is pretty much in line with what we discussed at level 1 of uncertainty when we have a clear enough future. So it's just a point or end state that will be always the same as we run this simulation over and over again. The second scenario would be when we run a simulation, a single simulation, on a model that has internal randomness. So we start with a constant input, so we are not changing it. We run the simulation, and as you see, there are multiple paths forward into the future states of this model. One of them will actually realize at that specific run, let's say randomly, if we set it to be random. So one of them will realize, and we see one path into the future of that system. Again, there are other paths possible, but we need to run it again and again to kind of see that. But one simulation will only show you one path. And if we look into the level of uncertainty, it would be if we are dealing with a real system that has alternative futures, we basically shed light on one of those alternatives. Or if we are in a range of futures, we found one possibility in this area. So as you can see here, so let's say, as I said, this deterministic case is not that common. We are not using simulation to mostly to deal with deterministic system. We are usually deal with a stochastic system. So we are here. And if you look into what we just did, if we run one simulation, we are just looking into one realization of the future. And this is not going to tell us what to do. This is not helping us with decision making because all of these paths are also possible. So we only saw one possibility out of many. And if we make a decision based on this, we are missing out on all the other things that could be completely different or materially different from what we just saw. So this is going to be only a descriptive analysis of that system. In the next few experiments, we are going to expand this with multi-run experiments to search more and be able to do more prescriptive analysis or decisions. So let's start by the parameter variation experiment. In a variation experiment, multiple iterations in which one or more input values are varied are run, we specify a specific range probably for each, let's say, parameter and run those to see these alternate futures. So let me explain what you are looking at here. First of all, one quick thing. When you are changing the input to a simulation run, we call it an iteration. So we have scenario 1, scenario 2, scenario 3. Each scenario is also called one iteration. So if I have a simulation and I changed its input, each of those would become one iteration because we are iterating over different alternatives. So in a deterministic scenario, we'll put our scenarios into each run. We run it, and each one of them probably result into a different value. And now we have access to all of these alternate futures. One thing that I wanted to mention is that when I say scenario, it doesn't mean that in a scenario you're only changing one input. You might have a set of inputs. Let's say this is a factory and you have the number of forklifts, number of workers, the working hours, and so on, all parameterized. So you might, in one scenario, change multiple input parameters. So just keep that in mind. But these are alternative scenarios. We run them deterministically. And when we run them, we will get to a fixed end state that we can identify. And then we kind of figured out our future states. But in a more realistic case, the internal of the system is a stochastic or random, as we discussed. So what's happening in these cases is this. So we are running these different scenarios, and if I run one of these iterations with a specific input, and I run it once, I only explore one path out of many for that specific input. For example, let's say we have a factory and we wanted to try what happens or what is our throughput if we have one forklift, two forklifts, three forklifts. If I run the model with one forklift, it shows me the throughput could be 100 units per hour, for example. So that would be one path, and that would be the result. But and I can run it with two forklifts, and now it says you have 200 units per hour, and three, and it might be 150. But as you see, in each of these cases, when I assign one forklift to the production line, there is still a possibility, if I run it again, that we fall into another path and some other result. Instead of 100, it might become 115 units produced. So this is not complete information, but it might, if you don't have that much variation inside each of these stochastic systems, it might be a good enough, and this might be a good way to just look into all the scenarios. But if you feel that this internal variation is significant, we can run a parameter variation experiment with replications. And the replication here means that we run multiple simulations for each iteration. What I mean by this is that, back to our previous example, if I have one forklift assigned to this scenario, I run this simulation with one forklift 3 or 4 times with the same exact input, and then I go to 2 forklifts and I run it 4 times, and now I have 4 data points for each scenario. And to make the output, and as you see, these red dots are not all going to be at the same location because they are representing the stochastic nature of the this model inner working. Now, to have a more stable representation of what's going on in scenario 1, I can take an average, for example, and have that as a representation of the expected value of what that value would be. And you see I have a average here represented with this black dot, another one here and here. So instead of working with one sample, now we have the average here represented. So these are more reliable, stable outcomes showcasing for each of these alternate futures. So that would be the parameter variation with replication. Next is Monte Carlo experiment. We start with the first order Monte Carlo. The scenario that you're looking at here is when you have a model that has inherent or internal randomness, and that's pretty substantial, or we care about that. And we wanted to see how that internal randomness is going to affect the outcomes. So we make sure the inputs are fixed, so constant, so we are not changing the inputs, and run this model multiple times. So you see this doesn't mean that we run it once. This is one run, and then we keep repeating, run again, run again, run again. And this is compared to the previous variation, which we have discrete number of alternative futures. This is, we are trying to fill this area. So we have hundreds, thousands of runs here. And eventually, this results into a distribution that showcases the distribution of that outcome and gives us some more probabilistic view into how the inner working of that system actually works. So this would be first order Monte Carlo, but we are also in reality deal with scenarios that the system is random, definitely internally, but the inputs are also unknown and coming from distributions. So here we are trying to schematically show that that you can have a system that has all of this built-in randomness in it, and you keep running it with different inputs, but the inputs that we choose here are not scenarios compared to the parameter variations. They are all coming from distributions. So these are random draws from these distributions. And we keep doing this, again, hundreds of times, thousands of times, to create a distribution or a histogram of the samples that eventually show us a probabilistic view of the range of possibilities in this type of context or scenario. And this is, again, is a good way to deal with uncertainty that falls under level 3, and we have a range of futures. And because we have a probability distribution of the outcome, we can make probabilistic distributions. For example, you can say, I want to my service level to be this value with 90% certainty, so you can actually look and see where you should go with your number of forklifts to hit that level of certainty based on your probability distribution. And the last one, which is also very popular and has been recently added to AnyLogic Cloud or Model Manager, which we showcased at an AnyLogic conference recently, and it is now released to the public, is the optimization experiment. The one that you use on AnyLogic Model Manager is using the genetic algorithm, as we discussed in the conference presentation. But back to what we are doing here, it is similar to some extent to what you saw in the previous experiments, maybe more similar to parameter variation, but with a big difference that in parameter variation, the scenarios are coming from us as the modeler. So we set, let's say with the design of experiment, or if we actually have some real alternatives in the reality that helps us just, we are confined by them. These are the limits of what we can do. So we put them and look into different alternatives. Here we have alternatives, probably a lot of alternatives, and we wanted to find which one works better based on a set objective function. And we don't want it to explore this range of possibilities manually because we don't know what are the scenarios. We just know the ranges of each parameter or the levers that we have, and we want to give it to an optimization engine. Basically, that engine will control these experiments and try different inputs to get to the objective function that we set for the experiment. So if you look here, if we have a model that is internally stochastic, the optimization engine starts different iterations. Each iteration means that the initial condition would be set by the optimization engine. For example, we have the option to have 1 to 10 forklifts. It tries 2 forklifts and run the simulation and gets the result. Then it tries 5 and look at it. And maybe goes back to 1 and try that. So these are not going to be exhaustive. So it's not going to do every single combination, because that's probably in most cases infeasible, and that's not what we want to do. So the whole purpose of this optimization engine is to be smart and choose these iterations or input parameters in a way that can find the optimum result in the shortest number of iterations, or the lowest number of iterations. And as you see, it ran different scenarios, probably hundreds, and it found different values, and between them, based on some objective function, it can choose one that satisfies or minimize or maximize a specific objective function. And when we found that, kind of say that this is the best, we go back and find the parameters that results into that desirable objective function, and that would be the setting that we will use for our optimization, or as our optimized value for that system. And if we wanted to take it to the next level, similar to what we did with the parameter variation with replications, we can do optimization with replications too, just to make sure that each iteration actually has more data points. By running multiple replications, we will have more data points, and we take the average of them to have a more stable representation of that specific iteration. And then when we wanted to compare and select the best based on the objective function, we are not looking into one of those runs. We look at the average of each iteration, which gives us a more stable kind of solution. And then if this is the winner, we go back and we know that this was the set of inputs that resulted in this best result according to the objective function, and that would be our optimized values for the input parameters. So I think, again, we tried with some schematics to showcase what types of experiments can be done. Some of these are I used from the Big Book of Simulation Modeling, which is written by Dr. Andrei Borshev, and I changed some of the other ones. So look at them as schematics, not real cases or instances. The intention was just to convey the idea to you. So now that we know what is possible and the kind of like conceptual ideas behind these multi-run experiments, Jeff is going to walk us through the next logical step, which how to prepare AnyLogic models to be uploaded to the server, and then how to create these experiments on the server with the help of AnyLogic Model Manager's user interface.
So in the next part of the presentation, I'll be giving an example of those specific type of experiments that we previously discussed, parameter variation, Monte Carlo, optimization. And in particular, we're going to be applying these examples to this example model. In this particular case, it is known as consumer credit, but it is just a bank where clients send loan applications either via in person, just walking into the office, or starting the process through the online application. What's really needed, though, for this particular system is the required staff for each particular step. Their credit needs to be reviewed. Each client has their own particular score or respective score, and some of them will be a success, some of them will be a failure. That is really up to a client's credential. What we especially care about is the number of abandoned. We don't want the clients to have to wait too long to get their application through and just give up because we just didn't have the staff to cover for them. And we're able to capture that not just through the number represented here on the screen, but some other statistics that we have included. I'm going to speed up the model just to populate these a bit. But we especially care about, obviously, the results, how many abandoned. That's that's not okay for us because that could be a potential new opportunity. Success or failure, that's kind of up to the client's personal credit score. We're also able to examine the utilization of all of our resources, the staff that actually needs the process to be moved forward, as well as the application life cycle. How long does it take for their applications to go through, whether it be through starting the process online, walking into the office, or purely sticking with just the online application, never working with an agent. And what I've already prepared within the AnyLogic Model Editor software are various type of experiments that I have access to, whether it be optimization of where we want to minimize the time and system for all of our clients for positive results, where we also want to make sure we don't have any abandoned calls as well by changing around the staff numbers. We also have just a staff variation model. Try all different iterations and permutation and different staff quantity and combinations, and just show me all of the average or all of the possible outcomes. In particular, once again, we care about number of abandoned and time and system, and in this particular case, we can also examine their utilization. I also have the ability to run a compare runs experiment, which is I want to stack different input scenarios on top of each other to directly compare the results. Maybe I'm tied between two specific cases that I really want to analyze further. And last but not least, actually second to last, we also have our Monte Carlo experiment, which in this particular case, for all the other scenarios I've created, one particular input is stochastic. It is static for every single run. In this particular case, the ratio at which they use that online application. But what if that is completely random? We're using what we kind of consider a historical scenario for the stochastic version, but what happens when historically it might change as well, and we need to see how that's going to affect the system as a whole. So what I want to do next now is recreate the same type of experimentation environment within the model manager software. And in particular case, I personally will be setting up all of the experiments that I want to eventually deliver to any number of end users. And maybe I want to specifically target a certain other user on my model manager to collaborate with this model with me. So before I even start the upload process, there are a few things I want to do to prepare this model. In particular, I want to make sure my parameters are configured in a way that allows for easy experimentation setup in the model manager environment. In this particular case, I also want to make sure I've included my Excel spreadsheet connection to this model that represents the rate at which clients arrive at, let's say, my particular bank branch, and set up some other outputs for our optimization experiments. In this particular case, we need to set up an output object to be represented as our objective function. First thing we're going to be doing is taking a look at those parameters, or input for this model. In this particular case, that is represented by these 4 parameters for each of the respective resource pools, or staffing amount. And all of them have their own respective default value. In this case, I want to set up the control types within the model manager environment, such that I want to make sure there's a minimum and a maximum that my users are allowed to choose for their various staff. To do that, I have to select my parameter, go to the value editor section, and make sure I choose my appropriate control type. In the case for all of my staffing quantities, I'm going to choose the slider option, which allows me to set what the minimum and maximum value would be. The only other difference will be application ratio, where it's represented as a double, either between 0.1 or 0.9, however fraction I want to represent that, but we're just going to keep that as a simple control type. To give a base example, I'm going to show you the type of local experiment I've created. In this particular case, I can choose any number of staff quantity and my application ratio and try out the different scenarios. But now, I would like to test this particular scenario out in a server-based environment and be able to have access to all those experiments as well. So the next thing we want to do to prepare this model, in this particular case, I want to, for formatting purposes, I want to make sure that my staffing quantity and application ratio are divided just like you see here inside this experiment. To do that, I have to click on my top-level agent, in this case main, and under my parameters preview, I can choose any option to add a separator, or in this particular case, begin a section, giving it a significant name, and doing the same thing for application ratio. This may seem very trivial at the moment, but this allows me extra capability within the Model Manager UI after I've uploaded this model. So now that I have my parameters set up, their ranges and their value editors, I want to prepare all the objects that I want available inside of Model Manager. So now that I have all of my parameters set up, the next thing I want to do is prepare my run configuration object. which allows me to select the type of inputs I want available within the experiment UI. In this particular case, it's going to be all those staffing numbers, the application ratio, and that previously mentioned Excel file that is representative of the rate at which my clients are arriving. And the next thing, I want to make sure that I have all of my appropriate outputs, in this case, all those KPIs and metrics that you saw while the model was running. Now, as you can see here, I have it previously set up, but it is very, very easy to pick and choose which ones I want. Maybe I only care about optimization, so I'm only going to include that output object that is represented by the mean time in system for a positive result. Maybe I care about only particular times in systems or particular histogram datas. But in this particular case, why not include everything and just drag the output section, and it just drops everything in and organizes it based on the layout that you see here. Now, the last thing I'd like to do here is add one little extra output object. In this particular case, this is more for any of my end users who want to utilize their own personal client rate. So think of every manager at a bank has their own historical rates that they're working with, but they don't know a template to use based on the Excel file. So I'm just going to give them an extra one just so they can download it on the web page. So the next thing I want to do is export this model to the AnyLogic Cloud. And to start, I just have to click this button. And I'm going to choose to create a new fresh model or experimentation page. Choose a meaningful icon. I do have the ability to include the model source files for other users to download, as well as give any user public access to the model. So for now, I'm going to uncheck this box such that the only person who can view this is me, the developer, because I would like to prepare some other experiments for my other users before I release it out to the rest of the AnyLogic Cloud users. And I'm going to include this checkbox here so that anyone has the ability to download the model source files and change any of the logic themselves if they'd like. So once again, we can review all of the files that will be included, and I'm going to click Finish. And once this upload process is completed, it'll navigate me to the general page of this model. For the time being, we won't go through every tab that we have available, because what we especially care about are the experiments. So here you will see it has saved those parameter previews that I've done. In particular case, that's staffing quantity, an application ratio that I can choose to hide or show whenever I'd like, and the ability to choose a particular client rate Excel file. So I do have the ability to drag a file to drag and drop, or I can navigate to a particular location and choose it, set any inputs in the particular range that, as I showed with the value editor, it stays between that range, and now I can hit run. In this particular case, what I'm asking it to do is run a single experiment to show me that output, and I don't need to see the animation. I just especially care about viewing the results. Now, at first glance, we could see here are all of the charts that we included, but it's a bit all over the place. I kind of want to perform some steps to organize it a bit more. So what I can now do is click the Edit Experiment or Edit Dashboard button. That gives me all of the sort of the under-the-hood configuration elements. Whether that be, let's say I want to hide a particular parameter from end users, change these sliders back to edit boxes, maybe give users some access to other experiment settings such as stop time. And what I especially want to do now is reorganize these outputs a bit more. So the first thing I want to do is, just for the sake of this example, we're just going to delete all. Just start with a clean, fresh slate. And why we're going to do this is because I want to start by adding some sections. And we're going to start by calling it credit results. And then I'm going to add a particular output. In this case, I know I already had a pie chart. And we're going to select the output, which it's able to access those single value metrics from my previous pie chart. In this case, the number of abandoned applications, successful and failure. But let's change this color scheme to be a bit more meaningful to us. Red being bad, we don't want abandon. Success is always very important, very great. And failure, we can leave yellow for medium. It's not great, but they at least were able to finish their application. So the next section I'm going to include here is going to be time in system. Because what I would like to demonstrate is, or to show, is those different application life cycles. Now, what I've done here is I've added another output object, chosen the histogram, and once I select output, if you'll notice I have somewhat of a different view with the output section because each output object is going to be contextual to the type of output objects that I've added. Now, what I mean by that is I've added a pie chart, so it's only able to look up those sort of single value objects. Now they've added a histogram, any form of histogram data, in this particular case, all that time in system, is going to be extrapolated and become available. In this particular case, I do have the ability to, let's say, stack all of them on top of each other such that they'll be aggregated into one single chart. But maybe I also would prefer to maybe try to stay a bit more organized and just replicate these for each of those particular options. And now I have the ability to have a sort of better examination of what these results will look like, try out any number of scenarios, and hit run. Or maybe I especially do care about animation and want to see this system as it plays through this configuration, so as to have the ability to just hit play, and it'll open up that same type of experiment, utilizing my inputs and showing the model with animation. What I'd like to do next is replicate those remaining experiments that I have created in the AnyLogic software here, between the optimization, the parameter variation, and Monte Carlo as well. And as you can see here, I have the ability to create a new experiment. Similar to the software, I have the ability to choose an experiment type. We're going to start off with optimization here, give it a meaningful name, and add it. So when it comes to optimization, there's a few extra steps that I want to do to the dashboard. In particular, if I actually go back to the AnyLogic software, many of you may be familiar with setting up the either discrete or continuous ranges for my parameters. I want the optimization engine to have the ability to change all of these different inputs, test the combinations, and test it against the objective function, which in this case is minimize that average time in system for a positive result, and making sure we're meeting our requirements, which is we want to make sure there are no abandoned calls, in this case no decision count. So to do that, if I navigate back to this model, I first want to edit my dashboard, because we could see here we have these sliders, but we don't have any ranges set up. So I'm going to click Edit Dashboard here, and I have the ability to well, in this case, only discrete ranges, because these are all integers. I can't change the type that I've already created. I don't want users to necessarily change the application ratio. Maybe that's not something we really want to focus on. We do want to make sure that they can see the objective function, but we also want to make sure that they can see the requirement, which is the application results abandoned. As previously mentioned, we always want that 0. Now we've set up all of our inputs. The last thing we want to do is, once again, let's not use the default outlook, but have some different sections for us to view. In this particular case, we're going to start with our first section of taking a look at the optimized results. And something that is wholly unique to the optimization experiment that can't be found in the other type of experiments available is the single value input. Now, what I am really doing here is saying, show me, if the model has run, show me what chosen input the optimization engine has chosen. We already chose those. And maybe I care about also taking a look at some of the data with inside the model as well. In this particular case, I really want to examine, well, what is that time and positive decision looking like? Maybe we don't care so much about the other metrics because that's not really what we're measuring here. And mind you, we also could hypothetically add another output object for our requirement, but seems somewhat unnecessary because we know that it's always going to be less than or equal to 0. Specifically because after we save this dashboard, the first thing before I forget is going to set that requirement to be that less than or equal to 0. I'm going to keep all of these ranges of 4 to 8. I'm relatively pleased with that. We want to set our objective function, which is that mean time in system for positive results in seconds. We want to minimize it. And let's give it more than 10 iterations or 10 combinations to play with, because we especially want to utilize the server capacity that we have on this particular instance. And now we can hit run. And what it's about to do is take all of those different results, batch them together, and run all of these just from my web browser, because it's all being run from my server. Even giving me the ability, if I'd like to, just close this window out. And sure, you think it's gone, it's disappeared forever, but within AnyLogic Cloud or Model Manager, it's always saving your results, whether it be for completed experiments, for while you're running. You're just allowing the server to handle all the hardware for you, essentially. So we can run through all the different experiments, combinations, but I'm actually going to transition to an already completed version that I essentially prepared for this webinar. So just right off the bat, going to run to my optimization experiment where I've run it already, utilizing similar types of inputs and requirements. And we can now definitely see what it recommends, 8, 7, 6, and 8, what that average result in this case, hours, and especially what we care about. We see no red, no abandon. That's really the most important things. And of course, we can have a further examination of the application lifecycle, staff analysis for what the utilization was looking like on sort of a staffing type basis, Or maybe we want to aggregate these results to see, is there some sort of interconnection between two of these particular groups that is occurring under the hood? That could be especially more pertinent to the next experiment which I'll be covering is variation. But the sort of last thing I'd like to do here is hit play one more time, particular for optimization. And what's a little different about this play button compared to the run is that it'll take those optimized results that it saw listed and now show what the simulation looks like with animation. So you could sort of take a look at the results yourself.
So Jeff, can you please go back to the experiment that is still running?
Mm-hmm.
Okay, it's actually finished, right?
Yes.
Okay, so one thing that we should also worth mentioning here is that depending on your use case and the complexity of the scenarios that you run, the private model manager lets you to increase the number of CPU cores that you assign to your primary node or to your AnyLogic model manager as a whole. So you can adaptively change the computational power that you need. So if you know that you're going to run these complex optimization scenarios with thousands of runs or with also replications and each one takes minutes to finish, then you have the option to add as many CPU cores as you wish to your system and let it to automatically balance that load between the available CPU cores.
You've kind of discussed of where the real power of this comes from, simply for the fact of if I wanted to have this type of scenario on, let's say, my very powerful laptop, it's the physical machine itself is a bottleneck. Multiple people can't access it at one time and try out their different experiments, especially because of the way that the local model editing software tends to be hardware greedy because it's, we're assuming one user, distribute all the power so they can get their results as quickly as possible. But here, all of that hardware is balanced between any number of users across the board. Within this particular example here, you could think about every bank manager within our business across the country is, let's say, working with a client rate that changes per week. And every Sunday, they can all come in here, test out their own different scenario, optimize for their own schedule and even maybe own restrictions that they might have, and be able to make a decision moving forward for that particular week based on the results. And to your point of, let's say everybody's accessing it on Sunday, it's going to be, you can allocate more CPUs on, let's just call it a heavy computational day, or also it's going to balance it all appropriately where all those number of users will get the results in a timely manner. It won't be like a wait in line for the next user's experiment to finish. No, it's going to distribute them all across.
Tries to be fair.
Yes, it does its best.
Okay, cool. So what else are we going to see?
So I wanted to show a few other completed examples of the type of experiments that you can design. I could walk through how I've set up every single one of these, but I want to try to be as conscious of your time as possible. So in this particular case, we have things like variation, which shows us we've selected the range. I want you to test all the possible inputs and combinations with this minimum maximum step. Once again, keeping application ratio static, all referring to my client rate. I'm able to change the seed and the stop time as I choose, but in particular, what I care about is the results. What was the number of abandoned versus this particular staff? We could sort of see where there might be some, we can already tell right here that it increased heavily when we were very low on consultants, so we can see a more linear sort of acceptance of, okay, we obviously need more consultants. These guys are a bit all over the place, but we also have the ability to, as I previously mentioned, check out the sort of aggregated results. In this particular case, let's actually examine the consultants and those bank clerks, because they seem to be affecting the system quite a bit, not just for success, but maybe we want to, instead of seeing it measured up against the success, I actually would like to do abandon, because once again, that's what we especially really care about. We don't want clients to walk away. We want them to finish the process. So we could sort of determine if there's a behavior between certain groups of staff. I also have the ability to run this same type of experiment, but with replications as well. In this particular example, same type of setup, but 10 replications. So it's just essentially more populated and averaged out data. Now, something I kept alluding to was that application radio. That's static. We call it 0.8, but that's essentially represented as an 80%. What happens when that isn't random? In this particular case, I also have the ability to perform Monte Carlo second-order experiments, where what it is going to do now is run this model with X number of iterations and replications, but application ratio is going to be incredibly random. And I changed the model a little bit to even be random for each particular user that goes through. So not only is their credit score unique, but their preference to that to use the online application is essentially all over the place now. So I can have sort of a more, I guess, chaotic look of what it might happen. Maybe it's not just about the number of staff quantity, but just the way people are utilizing that application, and is there anything we could do to speed that up? Maybe I want to examine, how long are they taking online versus the office and the internet bank it's very inconsistent.
And one other thing that I think worth mentioning is that as you kind of see throughout all of these dashboard creation process, Jeff does not needed to write even a single line of code. Actually, it is not even possible. So everything is happening through the user interface. It's extremely easy to set up, all point and click, and changing some settings, and pick from the options that the model manager provides to you. So what else? So we saw a variety of experiments. Basically everything that I talked about, Jeff has an example here, from the base simulation to parameter variation with or without replication, optimization with or without replications, and Monte Carlo, first and second order. So you can create all of them here in this environment. So now Jeff is going to show a few other kind of useful methods or tools that this model manager provides to you to gain more insight from the experiments that you run.
Thank you. So yeah, starting with some of the little features and functionalities, right as I've sort of already displayed on the screen here, you have the ability to, let's say, compare scenarios or specific experiments against each other. In this particular use case, you could think, okay, I've run optimization and let's just say tried some seeds and it gave me close but somewhat similar results based on different configurations. And I have the ability to, let's say, stack them on top of each other, choose any meaningful color I care about when assigning what charts I'm comparing against, choosing the red and yellow so that if there's any intersection between these two data points, it'll be highlighted as orange. And let's even say, you know what, I am very pleased with, going back to the optimization example, very pleased with these results. And of course, Model Manager is going to save these results. Anytime I revisit this page, it's going to always be there, but I also have the ability to download these results, whether it be as an Excel file that's going to give me this very nice high-level view of the model I was working with, what inputs were chosen, what the outputs came out to be, any data that was included, all those charts, anything I might want to know about that particular run, I can download and review for later. I also have the ability to download them as a JSON file, which is especially useful for all run type of views just due to its format, as well as the ability to, let's say, you want to take that data and analyze it in post-processing, such as a Tableau or any other sort of data analyzer. JSON also comes very handy for that. I guess the last few things to sort of discuss that it's just a feature of Model Manager is the ability to track and work with any versions. If, let's say, Rash here uploads his own, I actually have the ability to invite him as another model developer, such that we're both essentially owners of this particular model, and we have a shared repository between the two of us. I also have the ability to, let's say, share link access. I just want to, here's a quick hyperlink. Go straight to this model and experimentation page. Don't worry about logging in and all that. And I also have the ability to publish or unpublish it. And I can see any comments people might make. Hey, I found a bug. Hey, great work. Thank you so much. And the general page is just more description for this platform. Its name, categories, application areas, and any tags I might care about.
And these tags and names will help you to be able to search for the models that you want to find when you're filling your repository of models on Model Manager.
Correct. You could sort of use it as a little shortcut. So I don't have to always search consumer credit webinar. I could just search demo, and I know that this will show up immediately.
Okay, so I think that was a really great tour of how you use the default UI of the Model Manager to create different types of experiments, execute them, share them, compare the results of different experiments, and download the outputs. There are many other things that are that this platform can do, but our focus for today was mostly and exclusively on creating experiments and run them on the server. So thank you, Jeff. So in the next part, we are going to ask Tyler to join us again and walk us through how we can run these experiments through the API that comes with each model that is uploaded to the Model Manager. Thank you, Jeff.
Thank you.
Okay, so now that we saw how we can create these experiments with the user interface that comes with the AnyLogic Model Manager, Tyler now is going to show us how we can communicate with the models that we uploaded to the Model Manager and run any of those experiments that you saw through the API access. This opens doors for many different use cases that we discussed in previous webinars. I think if you look up and find our previous webinar on the AnyLogic Model Manager, you will find a variety of use cases that we discussed there. But today, our focus is mainly on the execution and see how we can actually use the API for running experiments. So, Tyler, please start.
Yes, very good. So to showcase this, I'm going to use an example model that's available in the built-in repository that I've modified. So in this model, customers come in, they're looking to get some credit, and they might drop out from the process for a variety of different factors. Specifically, in this scenario, what we're looking at is how the influence of the sales force, specifically our salespeople, have an influence on that. So each salesperson within this model has two parameters, one for the maximum number of customers that they can help at once, and also another parameter for their skill level, which influences their competency and their ability to help quickly. So within this model, one thing that I changed was to be able to load the population of salespeople from a local file. So if I go into the local model folder, there's the salespeople scenarios. And so in this file, I've designated different scenarios that can be run and different configurations of the sales force. So each one is a list of objects, and each object has the keys of the salesperson's parameter names and the desired values. And you see two different lists here because I want to be able to run one or more different scenarios. So if I go back to the model and run the basic simulation, you can see that I'm currently going to be running a scenario with index 0, which has 10 salespeople. And here you can see the model start to run. Our 10 salespeople are represented at the bottom here, and we can see how the model progresses. Similarly, if I switch this index to 1 and then rerun the model, now it'll run the scenario with index 1, which had 5 salespeople. And again, you could theoretically run this model till the end. So the other thing that I changed within this model, and I'm purposefully letting it run to the end to be able to demonstrate this, is that within the model, there's a recurring event where at the start of each month, it writes the entire state of the simulation model to a local JSON file. And so this includes everything from the variables to the statistics objects, even including the populations. And for example, for the salespeople agent, there are different statistics within that, in addition to the logic within the customer agent as well. If I go back to the folder here, you can see that there's now this logs.zip file, because at the end of the model run, I also have logic that zips up these files to a single output. And if I open up just one of the entries, you could see how this is organized into the different values, and then the customers, their states at the time of the snapshots, in addition to the salespeople as well. So we have all this information saved throughout the model cycle.
So Tyler, I have one quick question.
Yes.
If you go back to where you use the JSONifier object, can you please explain how you used this and where this JSONifier object came from?
Yes. So this is a custom library that I've written, which is available both as a standalone and also through my other library pipeline. And it allows you to do a variety of JSON-related tasks. So in this case, one of the functions that's provided is to be able to read a JSON file and then point to the index, point to that inner list, and then convert it to salespeople agents, and then add up to the salespeople population.
So this is downloadable for free from the pipeline GitHub repo, or as a separate repo, I guess, too.
Yes.
Right?
Yep.
So we will make sure to put the link in the description of the YouTube video that will be uploaded. And for everybody else who are watching it live, we'll make sure to send the link to you after the webinar.
Yes, indeed. And for the other instance, there's just a to.json file. This refers to this model agent. It adds pretty printing, so it adds new lines and tabs, and then this is the name of the file. So that's how the output works. And it has a variety of different customization options, so you can include or exclude different objects within your model, so you can customize the outputs. So going back to this scenario, I've set up the run configurations of the model to include the single file input, the other parameters as well, in addition to the outputs and the single file output as well with that zip file. And let me just close this to make sure there's no problems. So at this point, I can export it, save the changes. I've already had a previous version that I've uploaded, so I'll just create a new version. This will now upload. My concern here is not in the UI, but what I will do is showcase one thing that you need if you're looking for to use the API, which is your API key. So within your profile, if you scroll down, there's this section here with the API key. This is what's needed to be able to tell the whatever client that you're using, whether it's the Python, JavaScript, or Java, or the generic RESTful API, how to associate or identify you are who you say you are, essentially. And so this is a private key, and if that gets exposed for any reason, you can regenerate that. Because this is on a private instance that's only on our local network, because this is on a private instance that's only available on our local network, there is no issue with me showing everyone this key here. So I have everything that I need now to be able to switch over to my Python environment. So in this case, I'm using the Python API that's available for download here at the top. So this is the script that I'll be using and referring to in this example. I'm going to go over these things at a high level at least. So at the top here, we have various different imports, including for the cloud client itself. How the API works, at least for Python, is you create this single client object, which contains that API key and the endpoint. This client object is essentially the portal to between your programming environment and the model manager's instance. So from here, we can now call the get latest model version of the named model. And this version object contains just basic information about the experiment template. And so from this, we can create a variety of different experiments. The other thing that this script does is that whenever it's executed, it calls this upload file to upload this custom file that I want to use. And it returns a string of the hash that will be used as part of the functions that I'll call shortly. So this custom scenarios JSON file is located in my local Python environment. This has not only the scenarios that I showed before, but also a few other ones as well with a different set of configurations that we want to test. So now in terms of the model logic, I've written two functions here. One is for doing a single run. For each, whenever you go to run a new experiment in the API, you create an inputs object, which contains, as the name suggests, the names and the values of what inputs you want to use for that experiment run. So here it's passed as the string label or the name of each of these different inputs. And for reference, if I go back to the model editor, you can see that it pulls from these names here. And I'll go back to here. And then I set the value of this. For the file, I set it as that input file hash, and then which scenario index I want to run in the arrival rate of customers, which are taken from these arguments. We then create a new simulation experiment and then get the results. Here, if the results have not been already stored, it will run the experiment. But if they have been already previously, if that scenario, if the set of inputs, including the seed that is used, has been already run, it's able to just return the outputs immediately. Then everything else here is just about processing the outputs, downloading the output logs, and then using a custom script that I've written to be able to visualize that. So that's the single file run. I'll just go ahead and run this just to demonstrate this. So let me just go here, import my run script that I have, and then I will do a single run, and I'll start off just doing the 0th index and do the default prospects per day, which is 6. So I'll just omit that. Because I just uploaded this, it's now running the model in the background, and it's a relatively quick model, so it will print those results and then open up this page. Let me actually go back. So here what I've set it up to do is to be able to print in a table some of the outputs that are available from the various different output objects that I've uploaded. But the other thing that I've done is downloaded the log outputs. So I've used the download file function to be able to save that to my local model directory. And then my custom viz scripts unpacks this and uses the plotly Python library to be able to plot this chart here. So this shows how the different counts of the customers, not only at the end of the model here, but because I had taken those snapshots, I can essentially roll the clock back and see how the model changed over time. So this provides an alternative way to visualize and interact with the outputs of the model outputs besides what's available in the native Cloud API. So if you want to customize your outputs in any way, you could do that with this.
Sorry, Tyler. So the data that is behind this is all stored in a JSON format?
Yes. So it takes the output, it downloads that single zip file that has all those JSON files in it. It extracts that to a temporary directory, reads through all those different outputs at the start of each month, and then my Python code processes that into this chart and adds the slider here.
So you've now created a reversible simulation model.
Yeah, essentially, at least in terms of visualizing the data.
And this way of visualization, was it a specific visualization tool in Plotly that was available, or you created this thing?
No, it's part of the native library. So if I just open up this and go to where it was, it uses the native library here. And this, yes, it's called the Sankey. And then this Go is part of the Plotly.graph object.
So as you can see with this workflows, it basically opens up so many ways to use the outputs that you get out of the simulation, and the sky is the limit with all the other libraries that you can bring into the mix. This is just for visualization, but imagine how much of post-processing you can do on all of the raw data that comes out of the simulation. And one quick thing, Tyler, if you go back to your original code, can you just show or highlight the parts of this, let's say, single run function that are related to the AnyLogic so that we see how kind of compact is the model setup, and the rest is just you trying to create something around it. But I want you to just show that highlighted if you can.
Sure. So everything from, actually, this is all related to, in addition to these kind of global variables, this is what's needed to run the experiment itself. Everything below this is part of the outputs and processing that information.
Perfect. So I wanted you to see that actually outside of just configuring the model and pointing to which model you want, pass your key, then with a few lines of code, you set the inputs, you set up the experiment that you wanted to run, and that's basically it. The rest is you and the context of your workflow if you wanted to incorporate it into a web app, if in this case you wanted to use it for visualization or maybe do more data-centric post-processing, then you have the data that comes out of the simulation programmatically. And one other thing that I want to mention is just for larger groups that have different people with different skill sets, somebody with programming or let's say data science skill set may not necessarily need to know what's happening inside the simulation or how an OR or a IE expert created the model. They just use it as a black box to kind of provide input into their data-centric pipelines. That's another great way to collaborate between different members of a team.
Absolutely. And to those comments that you just made, after this part of the code that I just highlighted, everything below that is essentially for native Python programmers part of their bread and butter of what they're doing every day with data visualization. So it's, well, if you're not familiar with the Plotly Python library or Matplotlib, it's all very generic once you're able to get those outputs.
Or use ChatGPT.
Yes, exactly. Exactly. Yes, so moving right along, the other function is a multi-run. So here we're taking a fixed value of prospects per day, and based on that, we're reading through all of the different scenarios that have been defined, and then creating a parameter variation experiment. So here again, we create that single inputs object. Rather than saying just set input for the scenario index, here we're using specifically the set range input function. So we're telling whatever experiment receives these sets of inputs, it should vary over that. And specifically, this is for when you're running any sort of experiment that varies over a parameter. So in this case, it's parameter variation. So once again, this part of the code is what's needed to be able to actually execute or related to the AnyLogic Cloud Python library and able to run that. And again, it gets those results, running that if it hasn't been run, and then processing that. To this point, specifically to the types of things that Jeff has talked about, is that if I go to now run this multi-run experiment, because of the fact that all the inputs and outputs are saved, given that I'm using the same prospects per day, which is 6 for this, it's able to skip over the scenario 0 run because of the fact that that had previously been run by me just now. So it's only able to, or it only has to execute the experiments or the simulation runs for the other missing scenarios. So in this case, once again, it prints out another table of the different outputs and those values of that. And again, my custom visualization script writes this bar chart and this table and kind of does some post-processing on the outputs of the simulation model to aggregate some of the reasons why different customers failed, whether that's due to capacity, competency, efficiency, or some exogenous reason. So we could see, for example, scenario 1, majority of people failed due to capacity, which if we look at that, this table here, we could see it's likely because 5 salespeople isn't enough, even if their skill level is higher than the other scenarios. So again, after we get these results, it just comes back to a kind of standard data processing and analysis and visualization. It's not really AnyLogic specific anymore.
And one thing that I want to mention is everything that you saw, the way Tyler is executing this API is just manual. So you just run some code to see this experiment. But imagine in more practical setups, you might have some trigger points in the real system out of a database, some sensory data, something that triggers the simulation or the API to run these experiments. And then the feedback could be something like this dashboard that you're seeing on the screen that returns back the result to the end user or decision makers or people are controlling a specific system to and be warned or make decisions based on this future-looking feedbacks that are coming from the simulation. So just keep in mind that when you have an API, you can always automate the process of running the experiments as well.
Absolutely. So there's a lot more that you could do with the API running the other different experiment types. But these were just kind of 2 kind of basic scenarios. Actually, if you go to the AnyLogic help, so anylogic.help, and go under AnyLogic Cloud help, there's a section for the API specifically. This talks about how it works, the different ways that you can execute it, and then the different libraries that are available. And so if you were interested in For example, the Python one, it tells you the process of installing it, how to interact with it, the different ways and objects, how they're structured, the functions that are available. And then there's also this example section, which for pretty much whatever you want to do, there's both a textual explanation, and then also there's kind of these more drops downs where you could see some simplified sample code as well. So it's a great place to start if you want to get started with any of the APIs.
Okay, so I think we covered a lot in this webinar. We've seen a variety of ways that we can run experiments at scale on AnyLogic Model Manager, and I hope you enjoyed it. So next, Tyler, Jeff, and I will join you live for the Q&A session. Thank you. So I go through the questions, and there will be a couple that I answered, and I will ask Tyler and Jeff to answer them too. Okay, the first is, again, I paraphrase it because we kind of know what the question was. Is it possible to have different types of inputs or scenarios, but eventually when the simulation or different iterations, let's say, run, we land on the same answer? And the answer to this question is yes. It could be because the way the inner working of the model kind of dictates the result. There are multiple scenarios that are converging into one result, or it could be based on some random coincidence that two different scenarios with different inputs just have the same value. So yeah, it is possible. There's nothing wrong with that, as long as you can kind of go back and verify that it is logical. The other kind of general question is about training. If somebody is interested to learn more about AnyLogic and how to learn to use it and create experimentations and everything around it, how you can do it. If you go to our website, there is a tab called Resources, and under that you will find training and events. And there will be a list of events and trainings, and events are going to be like this, like webinars or other events that we have, and you can register for them and join us in our training. And the trainings most of them are online, so you can connect remotely, and they are in different time zones, so you can find the one that is applicable to you. Okay, so Tyler, I think this is for you. How does AnyLogic determine the parameter combinations in an experiment? If the number of possible combinations is way larger than the number of iterations that we set for fixed value. So paraphrasing it, you're usually typing and it's not that well said. So basically the question is, if we have many combination of input parameters that can be explored, but we set a limit for we set a cap on the number of iterations that can be run, which one of those subsets will be selected by AnyLogic to be run and explored?
Yes. So for the optimization experiment, because this is where I'm presuming this question relates to, it uses the optimization engine, which has some internal algorithms within it to decide what the next set of parameters should be based on the previous runs that it made, and then also the results of those runs. So in that way, it chooses the options that best lead it to the optimal direction of the optimized result, or one that might explore some unexplored areas of the space. So it's just based on the internal algorithm. And then the limit that you set cuts that off at whatever point that you specify.
Perfect. So the first part of the question is, what are the options for accessing AnyLogic internal database on the cloud? I think, Tyler, if you can talk about what are our options in accessing the internal or built-in database of AnyLogic when we are uploading a model to the cloud. And I will ask the same question to Jeff when we wanted to access external databases when we have a model that is uploaded to the cloud. So let's start with the internal built-in database, Tyler.
Yes, so if you just go into AnyLogic itself, create a model, create a table without any external data source, for example, an Excel file, and then you upload that. The state of the database when you uploaded it is how it will be. It's essentially frozen in that state. If you want to make changes to that, you would need to re-upload the model with the modified changes. However, if you're pulling from a local file, whether that's a Microsoft Access file or an Excel file, and that's what it's reading from whenever the model starts. In the run configurations, you could set that file as an input to the model. And so when you do that, that exposes a input in the model manager once you upload the model. And fortunately, the way that it's designed is that you can choose whether you want that input to be visible to end users or not, including the option to temporarily make it visible, upload a new file with the changes, and then make it invisible again. So you have those changes, but the end user can't then go and change it. Or you could just make it visible if it should be something that the end user should be able to modify.
Great. And Jeff, again, I repeat the question, how we can connect to external databases from a model that is running on AnyLogic Cloud.
Yes, for to make that connection, that essentially has to start with inside the model editor software, essentially the source logic of any simulation model you build, whether that be through the built-in database object found in the connectivity library, or any other, like let's say MySQL database that I had to import a JDBC driver for. Whenever you make that live connection, that connection will be maintained when the model has been uploaded. The only caveat I would say is, let's say we had to use one of those JDBC drivers that we imported, we just have to make sure that's included in the model source files as well, and that connection will be maintained just as it was locally.
And I would add to this that what you, Jeff, mentioned is definitely very comprehensive answer to how to connect from within a model to an external database, but with the API access to the model, you can also talk to a model at the beginning and at the end of the model run. So you can set the inputs that are coming from a database and then write the outputs to an external database. What Jeff mentioned was when you wanted to have this connectivity as the model runs during the runtime, which now you have answer for the entire time the model exists. And again, yeah, thank you so much for your time today and have a great rest of your week. Thank you.